be demoing Lopack version 3.3 today. As the program opens, it will be checking for updates on the server, and if there's a required update, it will automatically install. A recommended update will prompt the user if they would like to install. In the Getting Started tab, there's what is new in each of the subversions of version 3.3, currently on version 3.3.5, and it has the references for help and contact information. And this could be skipped at startup if selected in that first pop-up. The first tab here is the Legs tab, which you can see in the bottom left-hand corner, also known as the Baseline tab, which sets up project baselines, which could be used for different purposes within Lopack as well as for your project. To import a baseline into Lopack, select the Gear Setup tab here, and you can select one of the 4 options to import a baseline. First one being a plan line file, then a survey file, and then a DXF file. Or you could manually select input data points to create your own baseline from scratch. We'll select a plan line file. And it will ask for the station of the first point within that line file. We could just say station 10 plus 0, 0. And it will create the baseline inside this spreadsheet here with the each leg of the baseline separated by the points of inflection. So the first point of inflection would be the start point, which would be station 10, and then the X and Y for that, and then the next point of inflection, have the station and X and Y for that. And for each of the legs, it will calculate the distance and azimuth of that leg. Now you could export to a server file, plan line file, or a DXF drawing. You select the DXF drawing. And now if we open up that DXF, you can see it's created the baseline with the label baseline. We could also I'll show you how to load a DXF. It has to be a DXF with just one polyline. So we have one of those here from a Philadelphia project. And we can just say the start station is 0. Now the start station is based off of the first point in the polyline. And now if you don't know which side is which, or you can check that in AutoCAD, but let's say you mixed it up, you can hit the swap button here and it will make the other end of the line 0 instead and recalculate all the other points. Now we can export a plan line file, and as we open that up, you can see it's made a line file. Now with a baseline loaded into Lopack, there are various things within Lopack that use this baseline, such as the TMSC tab, which is the Mighty Station Calculator. It uses the baseline to calculate station range when XYZ is inputted, or it calculates X and Y when station range is inputted. For instance, on the Mighty Station Calculator tab is used for converting data sets. So we can import a data set, and the options are an XYZ file, border file, plan line file, target file, DXF drawing, edit or all format file, CSV or comma delimited file, a bucket file, a station ranges, Dredge database file, or you can manually enter in station range elevation or X, Y, and Z. So we'll choose to import in XYZ. Now it gives you the options to shift the data or clip the data. We'll choose both of these and I'll explain along the way. Shifting data, shown by this menu here. You can shift the data that's being imported in the X and Y directions in both positive and negative. So let's say a 10 there and maybe a -5 here. And it could be left blank. Any of these options could be left blank if you want. Station range is grayed out because we're not importing a station range. It's an XYZ. When it does calculate the station range, normally it does positive to the right of the baseline for the ranges, but you can select this to make it negative to the right or positive to the left. You can do the same as you did with the northing and easting and offset the Z. Shift it in positive and negative direction. The difference to level, we'll take a user specified value entered here and subtract each Z value in the data set by that value. You can also remove points based on the Z value greater than or equal to a user specified value, or you can also invert the Z. Now, it prompts you to find the XYZ you want to import. And now for the clip data portion that we selected, you can select one border file to clip the data to, or multiple border files, and it will simultaneously clip the borders, clip the data set using the borders, and it could be a mixture of in and out or just all in, all out. So we'll just pick one in border file and clip the data. So now it has imported the clip data and shifted data into the Mighty Station Calculator spreadsheet here. First column has the leg that it's correlated to in the baseline. And then it has an ID column, which in this case just numerically numbers the points. If you were importing a target file, it would put the ID for the target file. If you import a line file, it would put the name of the line file, so on and so forth. Then it has the shifted X, the shifted Y, and if we didn't shift anything in the Z, but it would have it shifted there. And then with all that inputted, it calculated the station and range based off of the baseline. Now we can export the data, and we can export it to a DXF, XYZ file, an AutoCAD polyline, AutoCAD circle, a target file, bucket file, plan line file, station range elevations. You can print the spreadsheet you see here. You can copy all the data in the spreadsheet to your clipboard. You can export to a comma delimited file or CSV, which is good for taking a CSV and importing it to a survey controller, or just any comma delimited function you may want, or a number of buckets, which is for a mechanical bucket dredge, for the operator's background while they're dredging to see how many buckets they need to take in each location. And at this point you can also shift or clip the data as importing before it exports to the file type. It will shift and clip the data again if you want. So for this demonstration, I will export to a DXF, and it has 6 different options to include into your DXF. You can select all of them or just one, or anything in between. For the first option is a polyline, and it'll make it one polyline based of all the all the data points. Next option is circles. Then you can do circles with crosshairs, circles with labels, blue circles with crosshairs, and you can select the color, and you can do custom colors, and it will show you all the colors possible with the DXF. You can cycle through. Hit OK. And select the radius of the circle. The next one is a line segment, which is just a line opposed to a polyline in AutoCAD. And it will make just the line segments of all the data sets. Next is a text, and you can either do the soundings, which would be the Z column, or the ID, which would be the ID column. You can select the angle, or you can leave it blank and it would just be 0. The height, I should say height of 1, and you could select the color here as well. You do a 3D polyline, and each of the vertices will have the Z value correlated to the data point, or donuts. So we could save the DXF. And it has created the clipped and shifted XYZ and has all the numerical IDs here with the circle with crosshairs that we indicated. I'll show another example. We can import in all format our edit file. And this is of a edit file from a single beam survey. You can import into the Mighty Station calculator depth 1 of the edit file or depth 2, or the difference between depth 1 and depth 2, and import it, and it would import just as it would with the XYZ as shown previously. Or you can convert the depth 1 and depth 2. So the first button is, it will make depth 1 equal to depth 2. The swap button will swap the depth 1 and depth 2. And the bottom button will make both of these depth 1. We'll make depth 2 equal to depth 1. Let's say we just swap it. So now, if you were to open up or look at your edit file, it has created all new edit files. Another option here is a Dredge database file. And let's see if we have one here. So this is from a bucket dredge. And now we can select in the database file, we have all these options that it records. If you want to import into the station and range column instead, like the station of the GPS antenna, we'll just do stick to the XYZ, so it's going to import to the XYZ column. So change it back to the easting of the bucket. Now we can select a time frame. You can manually type it in or use these buttons here. Time frame from when you want to import the data. If you want to just use the dig tracks, so if for this instance it's a bucket file, so only when the bucket closed on a bucket of material, a section of material, it would only export that instead of every location of the bucket. If it was a cutter dredge, it would only do it while it was digging. And if it was a trailing suction hopper dredge, it would only while it was digging, it would use those tracks. And it also has the option for a min depth to filter out the data more. You can leave that blank if you want. We'll just put a depth of 20. If you wanted to export the DXF tracks, you do that here, and also have the custom colors as well. If you want to save the clipped database, so after it's clipped using only the dig tracks and the time, after it filtered all that out, it would save the new database. And you can also export to a bucket file if it was a bucket dredge, mechanical dredge that was selected. So we hit done. And it's going through the full day's worth of recorded data. And as you see here, the baseline is not set up for the same project as what this database file was. So so it's going to be outside the project limits, out of the baseline limits. It would still calculate it if we hit yes. If we hit no, it just won't calculate station and range. So we enter in the bucket length and width because we just selected export to DXF. So I believe this one is 22 by 21 feet. And asking where we want to save the dig tracks. And now we have the dig tracks only starting at, we selected 4 a.m. I guess I didn't start digging to 4:25, so that's why that's here. And now we can look at our DXF if we would like. It has made a bucket file here with a polyline of each bucket, the 22 by 21, and the center point of each bucket, and in the color that we selected. Now let's say we can export that to a circle. Let's say you have a drawing already open and you don't want to export to a DXF. Open it, copy, and open up your new drawing, paste it in there. This is a lot simpler method. You could use AutoCAD circles and select the radius. And now you have it in your clipboard already. So now you can go to any drawing you want and then paste it in. And you can see that it has pasted in the circles. We can export a target file. And now it's asking what naming scheme would we like to take. Would we like to keep the ID as a naming scheme? Yes, no. If we select no, we could do in numerical order. So we just start 1, 2, 3, 4, 5, etc. Prefix to numerical order. So let's say, bucket. And we can hit OK. Save the target file. You can open the target file and you see bucket 1, bucket 2, and it has made a target file here. I'll import another data set here. Import in an XYZ. This is also not in the same project as the baseline, so that's why the error popped up. We can export in a number of a number of buckets. So we can either use a survey or a channel difference survey, depending on what the XYZ was, or whatever was imported into the Mighty Station calculator. In this case, it was just a survey that was on a 10 by 10 grid, I believe. The bucket bite is just the face that the bucket, the maximum face the bucket can take with each bucket bite. If you don't know how to calculate that, I'll show it here. Let's say it's a 30 cubic yard bucket. The bucket footprint is, the 22 by 21, and it'll calculate a bucket bite of 1.75, which is pretty standard. The grade, let's say the grade in this area is 50, so it will cut out anything that is below, that's already to grade. It won't show to take any more buckets in that area. And there's help buttons here. The target depth, let's say, maybe over depth is 52, but we want to stick the bucket all the way down to 53 because that's has been clearing grade a little bit better. Let's say so 53. And now we can round up or do the standard rounding. In other words, let's say you're only required to take 1.2 buckets in an area to achieve grade, or achieve the target depth. Rounding up on a 1.2 would make it 2 buckets to make sure you get every last bit. Or standing rounder is, if you see it working better with standard, 1.2 would just round down to 1. Now you can export as a DXF or XYZ or both. We'll just do it DXF. And ask for the DXF parameters for the text. The angle, you can leave that blank, it will just stay 0. The height, let's say a height of 4. You can keep it all black numbers, or you can make colors, and it has preloaded and default. So the first bucket will be color 10, and if there's 2 buckets in an area, it'll be color 20, so on and so forth. I'm gonna leave that the way it is. And now it's going to analyze and calculate the survey to see how many buckets is needed in each location. So it's going to ask where to save. Save the DXF. It's going to create it. And once complete, where did that save? We can open up the bucket map, and you can see this is a very large data set. How many buckets is needed to take in each location. So this would go to the background of the dredge. So you notice to take 4 buckets here, 5 buckets here, so on and so forth. There are many different options. I'm not going to go through all of them now. You can import in a DXF as long as it has circles, polylines. Import in border files and to get the XY from that. If you have station and ranges in a spreadsheet that are comma or space delimited, you can enter those in. You can convert those to XY. A CSV can be taken just as comma delimited file, or good use for it is from a survey controller. So they export in CSV, and when you click the CSV here, I could show you. This is from a survey. It has all the points from the controller, but let's say we just want to do these points here. Then you click OK, and it would import just all those. All right, moving forward here to the next tab is the Rod and Level tab, RNL. This takes any rod and level survey that you do and makes it into XYZ a lot faster than having to measure all the distances and everything in a different program. I won't go through how to do this, but what you do is just type in the first station that you're surveying, and then enter in all of your calibrations here, and then you would go It's asking for the minimum requirements here. Then you would just go enter in all the information. It goes through a whole wizard of what is you normally record in your field book. And if you need help on this, brings you to the routing level help menu here with a diagram to show what each is referenced to, the 4 site hubs and so on and so forth. And no matter what tab you're in, it'll bring you to the help menu for the Multi-Stage Calculator. Shows you here the tutorials online. Let's say you want to import an XYZ and export it, or a common thing is importing a line file and exporting it as CSV to put into your controller so you can survey on the lines. And you just hit convert here, and I'll show you how to the instructions on how to import and what is required, instructions on how to export, and you can hit shift data and show you how to do that, give you instructions. The next is the objects tab, very helpful tab to create object files. Normally, if they're not perpendicular to the line file, an object file could take hours to make if it's a very large area. So to do this very quickly, import the line file that you'll be using in your cross sections. And you import in a DXF. The DXF will contain polylines and text, just plain text, not M text. It doesn't have to have any text in it. So you can see here it has, this is the DXF, it has imported, and each of these dots are just text. This happens to be the dredging lanes or dredging cuts that the dredge is taking, and the labels are for each cut name. Now we can go through all the different properties for the object file. This would be the line properties, the color. You could select the type, the width, the text. You can select the font, the color for the font, and then the depth that you want all these texts to show at. And now the line depths. The start will make a line, is where the line starts. If you leave it blank, it would just be 0. The primary will be where does the line stop, what depth does the line stop, like say 50. If you put in a secondary line, it will put a strike depth at that depth. So let's say 48. Now if you want a strike depth at 0, you would select this. If you want it at the primary strike, if you want that to have a strike depth at 50, you'd put primary strike. Now the different methods here, the border method and the minimal text method, or just neither. The minimal text method will cut down, it will put less text in the object file. It'll just put the text in once instead of putting it at every line. So like, this point right here, it would just be correlated right into, it would just put it in once instead of trying to calculate it twice. It's recommended to use this one. A border method would be if you have enclosed polylines with a text inside of it. It will just create an object file more effectively that way. If you want the station name to show up, and then you can select the depth that you want the station name to be. 15. And dummy objects, what that does is, if for a certain line, let's say the line is outside of this DXF, it will still create a object file there. It would just be blank, or in this case, since I have station name selected, it will make a station. It'll have the station name in the object file. Now we can just hit create object to create it, or it's always recommended to do preview objects. So you can preview the object file. And now you can see here it has the line file with some of the line names here for reference, and the object file, the DXF. And now you can cycle through the object files here. You could switch through all the lines. Now if you had a problem with one of the labels here, you can select one of the labels and you can move it in any direction you would like. You can also add a text. Let's say you want to add a text, let's say acceptance section 3. I'll put that at DBL 1650, somewhere in the middle there, and at depth 10. And you add it to all lines, it'll recalculate. And now you can use this to make this the screen how you want it. And you can see I added AS3 to all the lines at that DBL. You can hit create objects. It's going to ask you where to save the log file. Now if we open it's created all the object files here. I won't open it up, but in the log file for easy input into cross sections. Now to cut down time, demo purposes, it might have taken a little bit longer, but it's a lot quicker and a lot more accurate a lot of times, instead of just trying to measure out by hand and typing in each DBL for each line, especially because these are on an angle, they're not perfectly perpendicular, so each line needs a separate object file. Next, I would like to show you I'll clear this out. You don't need to clear it. The borders tab. And what this does, it makes a border file from a DXF. Let's see if I have something here. Yep. So what this is, in this DXF, it has must contain a closed polyline. And I believe if it's not closed, it's coded to close the polyline, and a text needs to be within the limits of the polyline inside of it. And it uses text, not mtext. And we could cycle through these different cuts here, or these different areas, and it takes the name from the text that is and put it in there. And now you can move the dot here, and once it goes outside, you can see it change to out, or you could just do in and out, and it'll make the in and out. Use these scroll bars to move in and out. And now you can create the borders, and you can put where to select it. Or where to save it, rather. You can see it has made all these border files, one border file for each of the closed polylines in the DXF. There could be just one. These are the border files here. What the multi-clipper does is it will take a XYZ and it will clip using border file. or as many border files as you would like. So let's go to, and now it's made a border, an XYZ for each of the border files. You can see that these two here have 0 kilobytes, as there was nothing within those borders, but this one has data, and this one might have a point in it, or a couple of points. Yeah, there's a border. It created an XYZ based on the border, whatever was inside of it. And now the last tab here is called the Colors tab. And this is used for creating or editing color files, which are used to group together and differentiate soundings. So in order to open up a color file to edit it, you can click the Open icon and locate the color file. And from here, you can edit any of the levels or the colors by clicking the specified level and changing the color. At this point, now you can save the color file using this icon. Or you can create a color file by scratch by typing in the levels and then using the same method to select colors. And now you can use this icon here if you want to copy it to a AutoCAD drawing as a legend in order for bathymetry to display the levels for bathymetry maps. So you go into the paper space and then just Control V to paste, and now you have your legend pasted in to the drawing. That completes the demonstration of Lopack. My name is Michael Patria, the developer, and this is version 3.3.5. Stay tuned for more versions coming out in the future, and thank you for watching.